Hello everyone, my name is Rui Xie, and today I will getting started through a short introduction of the code summarization. So our paper is working on the scenario of the code summarization, which is predict a natural language sentence that describes a given methods. According to the previous researches, we can divided to these researches to two directions. The first is to design a better future representations to capture more accurate semantics of code. The second is bring more sophisticated deep learning technologies of text generation. So as a result, we also want to have a better representation of the code. Then we found the method names. And according to this table, it's noted that the method names should agree with the summaries. And so we want to use it to improve code summaries. However, during the actual programming, the method name cannot be good as them. Usually they have some abbreviation, conjunction, sometimes arrow. So this method names is hard to use. So as the purpose of using these method names to improve the code summarizations, we have our method deliberation multitask learning approaches for code summarization. So this is a two-step deliberation process. Firstly, we use the method body to generate his method names, and during the second pass, we have the generating method name and the human writing method name, and we combine it and use the method to use a model to deliberate which part is more important. So we have the method body. We combined all these three features to generate summaries of it. So following, I will introduce some details of our model step by step. The first is the first pass method name generations. So we use the sequence-to-sequence model here, and it's worth to mention that we introduce a new advanced structure-based traveler ASBT to here. Usually ASBT is transfer the AST type code AST type to the sequence type, as we can show the example here. But SBT always have some limitations, such as it cannot split the word simply name storage calends. So it will cause OOA problems. So we design advanced structure-based travelers to easily specify the SBT sequences to two sequences. The first is SBT toggle sequences. The second is SBT type sequences. So through these methods, we can separate it and to fix OOV, and also now we have a type sequence. We think this is more clear structural information of code. So we believe we can handle the semantic informations and the structural informations by our ASBT here. So here we have the generated method name and also the human writing method names. We first use a shared name encoder with attention to get his representation. Then we design another task which is called method name informativeness prediction. This one to calculate the informatic ratio, and then after this we we combine the attention and the mesonym scholar. Then after we getting the output from the fusion part, we combine it with the output from the body encoder with attention to feed them to summary decoder, and design another multi-copy components. And here we import this multi-copy components to copy the word W from all the meso body, human right mesonyms, and the generated mesonyms to let the code summarization, the final code summarization is more consistent with his inputs. And then we design operation stage and multitask training to improve the code summarization. And for the dataset we use is Java and Python, and the last Java is collected for pre-training. And here the experiments we did is first we combine with others. Second, we applied our frame with existing code enhanced models. It shows improvements. Third, we do operation study. Then we should pre-trained, we should get highest score. And also we test across programming languages, which is we pre-train on Java and then train and test on Python. Effectiveness of mesonyms, we train it with a masked mesonym, and also we do a case study to show the effectiveness. And that's it. Thank you.
Hi, very good day to everyone. Morning, afternoon, evening. So, welcome to this code summarization session of ICPC. So, there are three papers in this session. The first one, whose video you have just watched on exploiting method names to improve code summarization, is one of them. Unfortunately, we tried to get to the authors, but none of the authors actually appear in the backstage area. So we can't really ask the authors a question. But if you have something to discuss, you can just post some comment on the chat. And then while we are waiting until the next video will be presented in the next 2 minutes. I think it's exciting to see many more code summarization papers appearing in ICPC and also other conferences. And three of the various papers that will be presented in the session today, actually they discuss various ways to improve code summarization, the generation of comments given a particular piece of code, which is usually a methods. And many methods have been proposed in these three papers. Just now we have seen how method names can be exploited in order to generate a good comment that describe a method. And soon in the next 1 minute and 20 seconds, we will actually see another code summarization method that is targeted for a new kind of software, namely smart contracts. So in the presentation that we saw earlier, the code are written in the languages that is Java and Python. And in the next talk, we're going to see how can we create a code summarization approach that is targeted for the smart contracts. And the final paper of this session will be on improving code summarization with blockwise abstract syntax tree splitting. How we can actually split like a big abstract syntax tree into its parts in order to boost the performance of code summarization approach. Yes. Yep. So if you have questions for the next few talks, please